Welcome to Applications of Derivatives, Lesson 7, Interpretation of F prime graphs, where we'll look at a graph of F prime and then talk about what F is going to look like. Alright, so let's get right at it. First example here, example number 1. Okay, the question asks you, look at that graph shown of F prime, the derivative of F. Using the graph, find the critical values of F and identify each as a relative maximum, relative minimum, or neither. Justify your answer. B. Use the graph of F prime to state intervals where F is increasing, and then find all values where F of X has a point of inflection. Alright, A. Where are there going to be relative mins and relative max? Let's look at the relative max first. Relative max is going to happen where F prime goes from positive to negative. So there's a relative max at 2 because F prime goes from positive to negative at that value. Relative mins, where are relative mins going to happen? Where F prime goes from negative to positive. So there's a relative min at x equals 0 and at 4 because F prime goes from negative to positive at both of those values. B. F is increasing, the original function is increasing wherever F prime is positive. So F is increasing on 0 to 2 and 4 to infinity. C. Where are there points of inflection? F will have points of inflection when the slope of F prime changes signs. So we want to look at F prime and see where the slope changes signs. There will be points of inflection at x equals 1 and 3 because the slope of F prime changes signs at these values. Alright, let's move on to the next example. Example number 2, A. Given the graph of F prime above, find the critical values of F and identify each as a relative maximum, relative minimum, or neither. B. Use the graph of F prime to find the intervals where the graph of F is increasing. C. Find all the values where F of X has a point of inflection. Alright, A. Where is there a relative minimum? There's a relative minimum at x equals 0 because F prime goes from negative to positive at that value. B. Where is F increasing? Wherever F prime is positive, right? So F is increasing on 0 to infinity because that's where F prime is positive. C. Where will the F have points of inflection? Again, F will have points of inflection when the slope of F prime changes signs. There will be points of inflection at x equals 1 and 3 because the slope of F prime changes sign at those values. And that is quickly example number 2. Okay, let's look at example number 3 for a minute here. First of all, looking at that table, there are 4 points that we can plot. 0, 0 is a point we can plot. 1, 1 is another point we can plot. 1, 2, sorry, not 1, 2, 2, 0. That's a point we can plot. 3, negative 1, and 4, 0. Those are the 5 points that we can plot according to the table. Okay, on the interval from 0 to 1, notice that F prime is positive, so we have to increase And f double prime is positive, which means it is concave up. So we're going to go something like that. Trying to draw with this slate is not easy. There. Notice that f prime is undefined at 1, 1, so there must be a cusp here. And then on the interval from 1 to 2, f prime is negative and f double prime is positive, so it's decreasing and concave down. Alright, at 2, 0, f prime is 0, so there must be a horizontal tangent. And f double prime is 0, so there must be a point of inflection. And then on the interval from 2 to 3, f prime is negative, so we're decreasing. And f double prime is negative, which means it's concave down. Like that. And then on the interval from 3 to 4, f is increasing because f prime is positive. And it's concave down, so it's going to look something like that. And here is the graph, or a possible graph, of f. And actually, I think you're going to have one just like this on your homework. So good luck with that. All right, let's go ahead and move to the next example, example number 4. All right, example number 4. Looking at that graph of f of prime of x, A, find all values of x on the interval from negative 4 to 5 where f is decreasing. Okay, again, f is decreasing wherever f prime is negative. So where is f prime negative? It's on 0, 2, so that is where f is decreasing. Good. B, where is there a relative max? F has a relative maximum at x equals 0 because f prime goes from positive to negative at that value. C, where is the graph of f concave up? Ooh, that's a good one. You want to look at the graph of f prime and see where f prime has a positive slope, because the second derivative is the concavity. So wherever f prime has a positive slope, when you take that derivative, the second derivative will be positive because it has a positive slope. So f will be concave up wherever f prime has a positive slope. F is concave up on negative 3, 1. Sorry, negative 3, negative 1, got distracted there by having the wrong f. And it's also concave up on 1 to 4. Okay. Let's go ahead and then work on D, where we try to graph a possible graph of f. All right. So we're going to try to graph f here. All right, here we go. We're going to try to graph f. And what are we given? We're given some points. F of negative 4 is negative 2. That's where we're going to start. F of 0 is 5, right there. And f of 5 is 8. Alright, now let's look at the derivative graph. From negative 4 all the way to 0, f is increasing. There is a point of inflection at 3, at negative 1, at 1, and 4. F will have points of inflection there because the slope of f prime has a sign change. So let's see here. Is it concave up or concave down to begin with? Look, f prime is decreasing. So from -4 to -3, it's concave down. So it starts out concave down. Alright, I'm going to try to not use the slate. I'll try to use the mouse. I might be a little bit more successful with that, so I'll go ahead and try. Okay, it's concave down to begin with till we get to 3, and then it changes to concave up until it gets to where? -1, where there's a point of inflection. So it's concave up till it gets to -1. Sorry about that little bump there. And then it has a relative max at 0, so that's going to be a relative max, and it's going to change to concave down right here. So we hit that max, and we are still concave down till we get to -2, where there's a point of inflection at 1. There's a relative minimum at 2. And then it will change concavity again at 4, from concave up to concave down. And that is a possible graph of f. And let's go ahead and move on to the next example. First of all, where is f prime? Sorry, where is f decreasing? F is decreasing wherever f prime is negative. Alrighty then. So set that first derivative equal to 0. And then we're going to try to figure out which one of these will be 0. This will never be 0, so we don't need to set that equal to 0. How do we know it's not going to be equal to 0? Because we're always told that g of x is negative. So x plus 1 equals 0. X equals -1. X minus 2 quantity squared equals 0. Square root both sides. X minus 2 equals 0. X equals 2. Okay, let's use the first derivative test. -1. Let's say 1. That's not a 7. And 2. Alright. Pick a value less than -1. Let's try -2. Put a -2 in there. That would be negative. Put a -2 in there. It'll end up being positive because we're squaring it. And this will be a negative. Negative times positive times a negative. That's positive. Okay, let's pick 0. When we put 0 in here, that'll be positive. That'll be positive. That'll be negative. Negative. Let's try 3. Put a 3 in there. That'll be positive. That'll be positive. And that'll be negative. Negative. So, f is decreasing on -1 to infinity. And now let's go ahead and head up to the last example with 1 minute left. Okay, given all those things, what we want to do is try to figure out which one of these multiple choice answers is correct. So what I want you to do is first I want you to plot all 5 points and then come back. Okay, there are the 4 points, and you're told that f is continuous and differentiable, which means there are not going to be any cusps or anything. So the simplest graph we could possibly make to hit all 4 of those points would go something like that. And we want to try to make the graph as simple as we can. Okay, which choice is available? Alright, you figure it out, and we'll talk about it in class. This does end Applications of Derivatives, Lesson 7.